All right, we are here doing some rationalizing of the denominator. We cannot have a radical in the denominator, so what we do is, to get rid of that, we need to offset that radical by multiplying it by itself, and not just in the numerator, but in the denominator, both the numerator and the denominator. And what that does is these two, when you have a pair of similar or same exact square roots, the square root dissolves itself and it just leaves the number that you have under the radical, which is this case 5. Now here, 5 is just a prime number. I can't do anything else with it because it's just itself and not 1. This number right here, you can't multiply these because this is a number, this is a radical. So in this case, you would just leave this 5 times the square root of 5 over 5. And then, now I can look at this and I do have a fraction where the 5s are divisible. 5 goes into itself. In this case, it cancels this out right here. It's going to leave me with 1. Cancels this out, leaving me with 1. And all I have left is just the square root of 5. So the answer for this one would just be square root 5. Now, if we look at this one right here, we're going to multiply both the numerator and denominator by the root of 6. Now again, the roots will dissolve, leaving me just with the 6 in the denominator, which is what I need. It's okay to have a root in the numerator, you just can't have it in the denominator. Now here, I have this. So if I look at this, I have what looks like a fine, regular, ready to go fraction that has the denominator rationalized, it's gone. And the problem is the 6 obviously has 2 options, right? 1 in itself or 2 and 3. Now I have no other roots in here, so really that's not going to help me any because there's no perfects in either of those options. But I do have the 4 and the 6. 4 divided by 6, that can be reduced just like a fraction would be able to be reduced. And so I am going to reduce that because 4 and 6 both have 2 that go into it. So 2 goes into 4 twice. 2 goes into 6 3 times. So I'm left with 2 root 6 over a 3. And then this would be my finalized possibility. If you'd like more questions like this, you can find these on my Instagram, my YouTube, and my TikTok at YouWantAlgebra. These are all located in the roots and exponents section.